Let us suppose we have a function f of z equals to u plus iv. Now if this function is differentiable, then we will call it to be an analytic function. As I have written here, a differentiable complex function is known as an analytic function. Okay, so here I have written a function f of z equals u plus iv, where u and v both are functions of x and y. Now the question is that how do we check whether our complex function f of z is analytic or not? That means, how do we check whether our complex function fz is differentiable at every point in the z plane or not? So basically for that we use this formula. This formula is known as Cauchy's Riemann equation. So what do we do here? Now if you try to see, in this function we have got an u and we have got a v. Just we have to plug in those u's and v's here, and if this equality is satisfied, then we will call that this function is analytic. So let us first take an example. First we have got a function like this. Firstly we will be considering this function, which is f of x equals to x square. This function is a function of a real variable. As you can see, this is x square, right? So we can consider this function to be a factory where we are giving inputs x equals 2, then we will be getting output fx equals 4, and if we give x equals 3 in the input to this factory, we will be getting output fx equals 9, right? Because 3 square equals 9. So these functions are basically acting as a factory, right? In case of complex functions, the same thing happens. Basically, in case of complex functions, we give a complex input. As you can see here, I have given a complex input 2 plus i2, and I am getting an output 8 plus i8, which is also a complex number. That means a complex function is nothing but a complex number as a function of complex number. That is, if you give a complex number as an input, then you will be getting a complex number as output. Okay, fine. So let us just check the analyticity of this function, that is f of z equals to x square y plus I y square x. So here I have done this. Actually, u equals to x square y and del u del x equals to 2 of x y, and you can see del v del x del v del y is equals to 2xy. That means this first condition is satisfied here. Here we can see that the first condition is satisfied. But the thing is that when I differentiate v with respect to y, we get minus of x square, but when I differentiate u with respect to y, we get minus of x square. When I differentiate v, that means this function y square x, then we are getting y square. That is, this condition is not satisfied here, so we can say that this function is not analytic